started. Here's actually what the JFocus crew is thinking about Scala playing Akka, if you didn't know. My name is Henrik Engström. I'm a software engineer at Typesafe, and today, and most important, I'm also an Arsenal supporter. Today I'm going to talk about effective Scala. And first, a little slide about what we do at Typesafe, if you don't know us. We're the company supporting Scala, Akka Play, Scala IDE, SBT, Slick, and a couple of other things. Everything is open source under Apache License version 2. Akka is a framework that can be used from both Scala and Java, as well as Play, which is a web framework. And subscriptions is how we roll, which means that we want you guys to buy subscriptions so we can survive. But everything is free to use. Right, so today I'm going to talk about effective Scala. And according to my colleague, Josh, he thinks that effective Scala is optimizing your use of Scala programming language to solve real-world problems without explosions, broken thumbs, or bullet wounds. And Scala is a really powerful language, but you can get hurt if you do things wrong. So I'm going to try to summarize things that we've learned at Typesafe doing both Akka and Typesafe console and Play development. If you don't know, Akka, I hope you attended Jonas' talk where he presented a lot of ideas behind Akka. Akka is implemented in Scala, as well as Play framework, as well as the Typesafe console, as well as Slick and everything we do. We love Scala at Typesafe, but we also want to promote the fact that you can use Akka and Play from Java. Everything is compatible from Java. Right, so here's the agenda for today. First, I'm going to start off with some basic stuff about Scala, touch on object orientation, implicits, something about type traits, the Scala collection, which is an awesome collection of classes, really powerful. Touch on pattern matching, which is also an awesome feature in Scala. And then finally, do some functional programming things. As you can see, it covers a lot, so I'm just going to touch on each subject, and then you can dive into it yourselves if you're interested in more. But this is sort of the excerpt from lessons learned at Typesafe, and also from the really awesome book called Scala in Depth, which my colleague Josh is the author of. Right, so let's get started with the basic stuff. Use the read eval print loop that comes with Scala when you download it. It will become your friend, and it will be also a rewarding relationship. What I mean with this is, and here's an example of when you start Scala and go into the REPL, and you can do your the standard hello world thing printed to the command line here. Obviously, you can do more advanced stuff like that, more advanced stuff than that. You can, for example, explore things in the REPL. Like if you want to learn more about a jar and what's in it, you can put it in the lib folder under the Scala installation and start exploring by importing it into the REPL, and then play around with it. This is a really, really awesome feature. Let me see if I can show that for you. So here's how you start Scala. I'm on Scala 2.10, which was released like a couple of months ago or a month ago. So, for example, if I want to find something in Java, I can import it here, and I can by doing tab, I can get all the classes that are available under Java util. And let's do something with Java util random. So let's import it, and then I can create a new random instance like this. And for example, here I can also see what methods are available by using tab. So let's play around with next, and that seemed to work. And we can also So this is a really awesome thing of exploring APIs, and I encourage you to do so. Let me see if back to this. Right. However, the REPL has some drawbacks. If you want to write multiple lines, you can do that in the paste mode. But if you're in the IDE world, not using TextNote to develop, Eclipse has a really awesome thing called the worksheet, which was released late last year. Basically, what it does is the same thing as the REPL, and you can see here, for example, we're creating a variable called XS, which is a list of 1, 2, 3. And on the right-hand side, you can see what the worksheet evaluates that type to. So XS is a type. The type is list of int. So you get the type information back directly. The same thing for x equals 0, of course. And in the next part there, we have a while true, and that should go on forever, right? But the Eclipse worksheet is kind of awesome, so it realizes that that is a loop that's going to go on forever, so it sort of cuts it off after a while. IntelliJ are trying to do the same thing. However, if you were to write the last section there, it would go on forever. So, yeah, be careful when you use it. But it's going to get better. And this is also a very efficient way of playing around with things. Okay, so expressions versus statement or end statements. First, how many haven't looked at Scala at all? A couple of you, yeah. And I guess the majority of Java developers, right? Hand up. Okay, yeah, that's sort of 95% or something. Okay, so I'm going to do some comparison between Java and Scala. My background is also a Java developer. So in Java, you have to use like temporary variables to store results. Here we want to just print out the result if it's greater than 9 or less than. In Scala, however, everything can be expressed as an expression. So you can use the if statement directly in, or the expression directly in the print line. This is sort of a concrete example, but the next one is better. Here we want to, here we get rid of the temporary variable that you would have to use in Java by just expect the try catch actually returns. It always returns a value. So the result will always contain the value, so you can safely just print line your salaries. If some mischievous person would set divisor to 0, for example, then this would blow up, but the catch would take care of that and return the value to 0. So that's really awesome. Here's the pop quiz. You can actually do this with while loops as well. And the type of quiz here would be unit in Scala. So everything actually returns something in Scala. Returning something from the while loop maybe is not the best way, but I just wanted to show you. Right, okay, so the next part is fishing instructions. And this is also something that people tend to do a lot in Java. Here we have a method called find people and city, and we send in the city and also a sequence of people, which is a collection of people, and then we return a set of people that lives in that city. First of all, we start off by, this is sort of the anti-pattern. I'm going to show you how to do it on the next slide. But we start off by creating a mutable, a hash map, or a hash set containing people. And then we iterate all the people, and then we iterate the addresses of all the people, and then we check finally if the address, the city of the address equals the city we were after. Then we put it in the hash set and return the hash set. So that's what you typically would do as a Java developer, right? In Scala, we instead of telling it how to fish, we just order fish. So here first of all, we have the same method handle, of course. And then we use a for expression. And it's important to point out that the first line in the for expression is the type that's going to be returned. So first I want to convert the people from a sequence of people to a set of people, because that's what we want to return, right? The method says that it's returning a set of people. So then we extract every person in that sequence, or every people, we should call person maybe, but yeah. And then we get all the addresses of that person, and then we have the guard. If a city address of city equals city, then we yield P, which basically means that what's going to be returned is a set of people that lives in the city. And you can compare this with the SQL. It's a SQL-like syntax where you have from, people, and address, where people address equals A, and here I put the city London, and then we select P. The cool thing about this, by doing this, is you rely on the implementer of the functionality to choose the best algorithm for you instead of choosing it yourself. So, and you also, by doing this, I mean, if you choose the old one, then you might do an inefficient way of extracting values. But here we rely on the people or the implementers of the functionality to select the best functionality for us. Okay, next thing, always stay immutable. As Jonah said on his talk before, immutability is the road to happiness. Mutable safe code basically means you have to clone everything. So here we have a class called football player, and since every football player always had a lot of cars, we want to store those. We chose the mutable collection array here, which basically means that whenever someone sends an array of cars, the set cars method here, we have to clone it before we store it locally in our class. Otherwise, they can actually manipulate our inner state by adding things to the array outside of this context. And the same goes for when someone calls the method get cars, we need to clone it before we return it. Otherwise, they can actually poke into our state, right? So when people say that, well, programming with immutability it costs a lot because you have to always, it's lower performance. Well, take into account that using safe sort of protecting yourself, you always have to clone, and that costs even more than using the immutable collections. And immutable collections are also very performance efficient, straight from how it is. So performance degradation is something that you really has to take into account when talking about speed. Right. Here's a safer way of doing it. Instead of using array, we can use vector, which is a mutable collection. So whenever someone I should say actually, there's something wrong here. It should say vector instead of array there. Right. So when someone passes a vector into us, we're safe to just say, okay, our cars is equal whatever they pass, because we know they can't change the state of that collection. So bear in mind, it should say vector instead of array there. Even better, in Scala we have something called case classes. And you just add the word case instead of in front of the class. So here I create first a case class called car, or you pass in the brand. Whenever that's been done, we can't change the state of it. So, okay, and then we have the case class football player, which has 3 parameters, name, team, and cars. And we can also set things to default values. So we start off with an empty vector. So that basically means that we can instantiate a football player by just sending in the name and the team. Of course, it's Arsenal. An important thing to point out here is that case classes, you don't have to even use the new keyword to create a new instance as well. So then we do player to string, and we get the football player, Thierry Henry, Arsenal, but he hasn't got any cars yet because we chose not to pass them. So then we can actually alter the state of the player instance here by using the copy method that comes out of the box with case classes. And in this case, we choose to copy Thierry Henry, but we add a car to him as well, the Porsche. And as you can see, the end result then is he has a car. Note that we're using var here so we can copy the value. Normally I would encourage you to use val, but this is just an example. And you can also try this. This is in the REPL, so you can try it out in the REPL directly if you want to. So here are the immutable class benefits. You have better simple equality and simple hash code because you know the state will never change, so you can use the variables in it. No need to lock, no need for defensive copying. And also, if you use case classes, you have automatic equality and automatic hash code. And it's using murmur hash, which is a really efficient hashing algorithm. Okay, so here's something that I wanted to point out. Whenever you're inside a method, it's okay basically to use, I think it's okay to use mutability if you know you're going to change the state of something a lot. Like we're just going to put a lot of variables or ints into the array buffer and this populate data, and then I'm choosing to return a sequence of ints. So we can't change whatever is being passed out. We can't change it. This example is almost okay because we're returning seq, and I'm going to talk a little bit about sequence later. There's some loopholes in it, but the concept of passing out a mutable, using a mutable collection, do your stuff, and then sending out an immutable version of it sort of saves you from knowing that someone can change the state inside of you. Okay, next topic is options. As Java developers, you're aware of this null game. You have to check everything, like if users equals null, password equals null, if user's empty, password's empty, and not can authenticate in this example. Then we return anonymous privileges. Otherwise, we call privileges for an user. And this is typically what you have to do always when you do development in Java. Don't do this in Scala. Instead, use an option wall. Basically, send in options of strings, and then use a for expression to extract the values. So here we extract user and password. So the U and P variables will now contain values. If user or password, on the other hand, is none, so an option can either have a value or it can be none. If they're none, then it's going to return, yeah, I'm going to come to that later. So here we go, user, password, extract values, and then we check if they're empty, and then we check if we can authenticate. Then we call privileges for that user. And now you can see I'm returning that to the variable privileges. And the last line here is privileges, if it's got a value, then it's being returned. Otherwise, we return with privileges anonymous. So now it's sort of reversing the whole idea of thinking. So using options and the for expressions is really powerful, and it saves you from this null game. Right, so that was the basic list. Moving to object orientation. Whenever you're, so a trait in Scala is sort of a combination of an abstract class and an interface in Java, which basically means you can have implementations in it, like area here, for example. So we're defining a squared shape interface, and we want people to set the width and height, and then we have a method that we provide for them called area, which is it returns the area. And then in the class rectangle, we provide width and height, and we extend our interface or our trait, and then we override the values, right? Cool. So let's create an instance called rectangle R1, and then we check the height. Yeah, that seems to be okay. It returns an int. It's 314. And then we call area, and that's sort of not correct. It should be 314 as well, right? And the reason that this doesn't work is that Scala always instantiates the base class before the child class. So default value will be set on width and height, and default value of an int is 0, so therefore it's returning 0. So don't use vals for abstract members. Def is much, much better. It sort of hands over the programming power to the implementer of the class rectangle. So you say you provide this trait squared shape, and then you give it to someone else. Then they can select of using override here, as you can see in the last example, or even better with a case class. So the case class will then match the variables you set width and height here to what's in the trait. So it works out of the box. So it sort of gives, you can even use a var if you want to. You can override def with a var. So it hands over the programming power to the developer. Okay. In Scala, you don't actually have to annotate the method, what it's returning, but I think you should in case of complex, if you have complex code. Otherwise, you have to compile it sort of yourself. I mean, I don't mean the compiler compile, but you have to. You look at this code convert, and it's returning something you're not sure, and then you check the code. Okay, so here we have pattern matching. So if x is 1, then we're returning a 2 character. And if it's 2, then we're returning a Boolean. And if it's something else called C, then we're returning a byte. And this, we have to understand the sort of class hierarchy in Scala to realize that it's an eval that's being returned. So it's much better if you just annotate that. It doesn't cost very much. So I encourage you to do that. The readability is much better. Also, annotations of what's being returned is a really good way of documenting things. So especially if you're writing an interface or a trait here, always annotate what's being returned. And also, it gives you sort of the existential property here, like option. Then you know it could be int or a value or none. So much better. So always document the APIs. Okay, next topic is composition and inheritance. Composition is always preferred over inheritance. It's easier to modify, and you can use dependency injection like they do in Spring, for example. In Scala, composition can use inheritance as well. And this sort of leads off to the famous cake pattern. I don't know if you've heard of it. We're going to go through an example of how to bake a cake. So let's get on it. So the cake pattern is a pattern to sort of use dependency injection without using a tool for that. So here's how to do it. First of all, we create a user repository component, and this component contains two services, a user locator and a user updater. And then we define these traits. In the user locator, we can call the method findAll. It's returning a vector of users. And then we have the user updater. That's just a save method. So that's the interface definition. And now we're going to provide a JPA user repository component. So we extend the user repository component called JPA instead. And you can see here, we're overriding the methods called the user locator and user updater, and providing instances of JPA user locator and JPA user updater. And these implementation classes need the entity manager. And the entity manager at this point is still not defined. So the details of the actual implementation here is not important, but it's just to show you how to do it. But we have concrete implementation. Now we have a JPA user locator that can look up all the users, and we also have something to store, to save the user with. So now we've defined the sort of repository layer. Let's move on to the service layer. And so we define, in the same manner here, we have a user service component that contains a user service, and it contains 3 methods at this point. So I've added a check status of user. That's sort of the business logic in the service layer. The other ones are in the repository layer. Apart from that, it's equal to the repository component. Okay, and finally, we provide a default user service component. So this is extending the user service component. And next step is really what sort of is the important thing, the self-annotation type. By doing this user repository component, you're saying that whenever someone implements this interface or trait, they have to provide a user repository component as well. And this is the dependency injection, you can say. We also provide a default user service. The default user service in this case is just going to use the user locator and user updater. And finally, the check status, which is not using any underlying service, is just a string interpolation, which is something that we have now in Scala 2.10. By putting an S, you can actually, you see the user, the $user there, is being extracted from what's being passed to it. Okay, so here's how to use it. We have an application, and now we're sort of cooking the whole cake here. We're creating a component service with the default user service component and with the JPA user repository component. And if you remember, JPA user repository component, you had to provide an entity manager. So that's what we're doing. We're implementing the entity, or providing the entity manager as well. And then we're free to use the service, whatever service we want to use, service, the three methods that were provided. So that's, you're sort of deferring the actual implementations to when you're using it. You're not, in the lower layers, you don't know exactly what implementation being used. That's sort of deferred to the last layer where you want to use it. And by doing this, you can also test it, right? We can provide a mocked entity manager and just create a component service and then perform the tests. So we can use this as well. And people are taking this even further, like Precog, which are heavily into Scala. They don't even use mocks. So they're using Cake for everything, and they love it. This was actually taken. This example is taken from Cake Solutions, a company in the UK. They actually have a really good blog that I encourage you to read. Right. So that was object orientation. Let's move on to implicits. Implicits removes a lot of boilerplate within the context, and it provides compile time safety, and it must be unambiguous. And I'm going to show you what that means. So implicits is a really good thing, right? Let's create an implicit example here. We have a trait called auto repository, and you can see that it has a method that accepts a registration ID of a car, and the next line there, on the right hand side, we also say something implicit DB-ID. Basically, what this means, instead of putting this into the whole method, the first method, as another parameter, we're using implicit, and I'm going to show you what that means later. But we move it on to the right-hand side of the method, and this find method is returning an option of cars, and the same for find all is just returning a sequence of cars. And the implementation of this then would look exactly the same. I'm not providing any implementation here because it's not really important, but you can see it also has the implicit on the right-hand side of the method. Right. So that's what you have to do. Now, there are two ways of dealing with this. Either in the car finder class here, that's going to use the repository, we can provide first you see I created DB-ID here. DB-ID, the idea is to know what database to look in, basically, or whatever, what repository to look in. So we can actually explicitly provide this by adding another parenthesis to the method call and DB-ID, but this wouldn't really change anything from just having two parameters to the method, right? So here we're not really utilizing the power of implicits. Instead, we would just add a value or the keyword implicit instead of in front of the DB-ID up there on the first line, and you can see I don't have to provide the DB-ID anymore to the method calls because the compiler figures out where to. Oh, here's an implicit variable, then that's going to be used instead, so it's sort of being replaced behind the scene for you. Right, so it's really powerful. However, it also means a lot of compiler heavy lifting, right? Because there are some rules around this. The scope for how to look up implicits is kind of complex. First, you look in the compiler looks in the lexical scope, the current scope you're in, any explicit imports, any wildcard imports. If it can't find any implicit, it moves on to the companion object of the class. You can think of the companion object in Scala as a singleton that belongs to the class. Right, so then it continues on and looking further and further away from where you are. So this can cost you a lot in compile time. So you should use it with care. And there are some patterns for how to use implicits better, and I'm going to show you one. So implicit values here. Here we have a trait called logger, and it's just got a method called log. But not only, so that's sort of the trait that we want to give to the world. But we're also providing the companion object implementation here. So you can see it's called the same thing, logger, but we use object instead. So that's the companion object. And Now we're providing an implicit object here called default logger, and it's extending that trait logger. And we provide a print line in this case, just default logger and then the message. And you can also see that I'm providing you can think of it as a static method called log that takes an implicit logger. And this is in the companion on the companion object level, and this is really good to do because it means that now the implementer of the class that's using the logger can decide to override this, right? Because if you remember, the lexical scope was first in the class on the class level and then moving on to the companion object level. But at least we've provided a default logger, so let's try it out. We just call logger log, it's small test, and then it's going to print DL is small test, right? And now we decide, no, we don't really like this DL prefix to method. We want to do something else. So, okay, let's provide, let's create a new implementation called myLogger, and instead of DL, it's just saying my and printing the message. Not really fancy stuff, but it's just to prove the point here. And then in this context, we do implicit def myLogger equals new myLogger. And this basically means that now myLogger has overridden the implicit context. So now if we call logger.log, it's going to print my instead. So it sort of defers the power or the implementer to decide if they want to override, but we also provide something out of the box. And this is really an efficient pattern for how to use implicits. There are some implicits wisdoms found on Twitter, which basically means that if you're overusing implicits, you might end up in bad situations. So use it with care, but it's a powerful tool. Okay, let's move on to type traits or type classes, which is a concept that's sprung out of Haskell. It's basically describing a generic interface using type parameters, so the implementation can be created for any type. So here we have, again, a trait, and it's called encodable, and it's expecting a type, T. And then it's got two methods, from and to. And here we're using the implicit values pattern again. So in the companion object encodable, we're providing an int encoder out of the box. So we know people are going to use int encoding a lot, so therefore we're providing it, but if they want to use another encoder, they can provide it themselves. And in this case, the from method just adds an int and then the value. And the to method just extracts the actual value. Right. So let's use it. We create a class and it's got two convert methods, and it's expecting an implicit encodable. So you can see I'm using the to method in the encodable and also the from method. So we can try it out. Let's create a new handler and then call convert 1, 2, 3, 4, 5. And then it's printing, as you see, int 1, 2, 3, 4, 5. And then we can convert the result back. In the REPL, the res0 is a variable that you can use. So you can put that, you see I'm using that value in the convert method on the next line. And then it's returning a new result, and it's the expected 1, 2, 3, 4, 5. Okay, that's cool. Let's call my handler convert with a long instead. No, that doesn't work because it can't find an implicit value for that, right? And that's what we're expecting. So let's provide one. Okay, let's implement encodable long. It's got the same functionality. It's adding long instead. And you can see when I'm doing this in this context with the implicit, now I can convert longs as well. Okay, that was touching on the power of type traits. Next up is collections. I'm just going to touch on I'm just going to mention that collections in Scala are absolutely awesome, believe me. So play around a lot with the collections, and here's sort of the starting hierarchy. We've got plenty of classes here, so have a look at that. One way of doing that, of course, is using the REPL. So here we're just creating a sequence, and then I write seq dot, and then use tab, and you can see these are not all of them, but these are some methods that are provided, and every collection class in Scala has got flap, map, fold, and so on, so you can use these functional approaches of handling your data rather than the mutable that we're used to so functional immutable rather than mutable we're used to using in Java. Okay, message to all Java developers, and there are quite a lot of you here today. Don't use list when you come into Scala, because you're using array list in Java. Use vector instead. Vector is much faster than list, and vector is more memory efficient than list, at least for larger collections. So always use vector instead of list. Don't just remove array and use list, vector. So here's what I talked about a little before regarding sequence in Scala. So I didn't mention this, but for you who don't know, in Scala, whenever you're using map or something and not explicitly defining where the map is taken from, it's going to use the immutable map instead of the mutable version. In Scala, we have mutable versions and immutable and also parallel collections. So out of the box, if you use map, for example, then that's an immutable map that you're using. And when you start playing around with this, you don't think about it. You just know that it's an immutable, right? But for a sequence, it's not. It's actually the Scala collection sequence that's being returned. And this sort of can open up Pandora's box for you if you're not careful. Because it actually means that someone can change the state of your inner state without you realizing it. So use sequence with care, or at least be aware of it. It's implemented like that because sequence is using array, and array in Scala and Java are actually the same implementation. So. Yeah, there's a long article on exactly why it's being done. That's the reason behind it. Okay, so pattern matching is the best thing since sliced bread, I think. It's a really awesome feature that you can use for basically anything. Here's how to pattern match sort of functional programming in a functional programming manner. In Scala, whenever you're doing something that you believe is tail-rick, you can add the annotation and the compiler will tell you if it is tail-rick or not. So, and this is really important because if you believe you're doing something tail-rick, then that's efficient. And if you don't, then it might blow up on you if you're doing too many recursions. Right, so here we just pattern match over a list called L. So you can see L match over there. And then I have two cases. Either I can extract the head and the tail of the list directly, and then call myself at once again, but adding 1 to length. Or if I'm at the end of the list, nil is being what I'm looking at, then I'll just return len. So here's how to call it. We call it with a list of 1, 2, 3, 4, 5, 6, and then we provide the default value 0, and we return. It's being returned 6. So that's how to use pattern matching in a functional manner. But you can also use it for a lot of other things, like extracting values. And if you're using instance of in Java a lot, don't use pattern matching instead. So here we're sending in an animal, and then we're matching it to a couple of different classes, dog, human, and walrus. So if you can see that I'm actually extracting the values as well, the variables from the case class here, dog, name, and age. Then I can use age directly and just multiply it with 7 and return that. If it's a human, I'm returning its age. I don't really care about the other variables. It could be name, age, and something else. Gender perhaps, but I don't really care about that. I'm only interested in the age variable, so then I can just do that with the underscore there. You can also use explicit values, like on the next line. We're only interested in the walrus dunny. Then we divide by 10. But we can also add guards, as you see in the last line. If name equals Walter, then we return age. And finally, the default case is the underscore, which is going to be everything else. If someone passes in a bird here, then 0 is going to be returned. So that's really powerful. Play around with pattern matching. It's a great feature. So parallelism and concurrency on one slide. It's very difficult to do. So don't play around with it. Use actors or futures instead. And I'm going to leave it at that and look up Jonas' talk about why it is like this. It was on the session before. If you're doing Java integration, you have one team implementing in Scala and one in Java, and you want to provide the functionality. Here are some pointers. Always write the interfaces in Java instead of in Scala, because if you do in Scala, then you might unintentionally expose functionality that looks weird in Java. For the Java developers, they get all mad and saying, what's this Scala weird thing? So write the interfaces in Java, and then the actual implementation in Scala instead. So the Scala team is happy. They can use all the cool features, and the Java team is happy. Also, try to use Java primitives, because in Scala we don't have boxed and or primitives, boxed values. We just have one version, and this sort of saves a lot of work for the compiler going back and forth. So use primitives if you can. Okay, so functional programming covered in 5 minutes. So first of all, I would encourage you to look at functional programming. Martin Odersky has a really good course on Coursera where he goes through a lot of concepts in functional programming. And it's free, so you can just play around with that. However, when I, as a Java developer, started looking at functional programming, I got all these weird words in front of me, like functor, monad, applicative functor, and so on, and I didn't really understand what that was. So it can become sort of, you look at it and you get scared, but it's not really scary. I'm going to show you. It's just fancy words for something that we're actually using without thinking of it. So here we have an example. This example is also touching on the subject of using asynchronous programming rather than synchronous, which Jonas talked about earlier. So we're returning futures. So we have a server that's got an API on it, a person repository, where we have two methods, getFriend, and it's returning a future of a person. So it's going to be returned, but it's not going to be returned directly to us. And the same thing we have a friend_sub, which is returning a future sequence of persons. And then on another server, we have an interest repository where you pass in a person and you get a future of sequence of interest back. And finally, we want to render this on the front page. So we want to return a class so we can render it nicely in HTML5 or something. This class, then this case class, expects a person, a sequence of friends, and a sequence of interest. The friends should be sequence of person, but yeah, you get it, the idea. Okay, so this is sort of what we have to work with. How do we actually use this now? Well, we create a method called getData where you pass in the name. That's something we need. And then an important thing here is that we're returning a future of something. We're not returning the actual value, because by returning the future, we can stack these on top of each other, which is exactly what's being done in the next couple of lines in the for expression, where I first of all say I'm going to call the person repository and get the person with the name, and the future piece being returned. And then we're going to call the person repo again with the friend sub p and zip that together with the interest repo interest sub p. And everything here is being done asynchronously. And when that's being sort of done, we yield the result back to the front page context. It should say future front page context, but yeah. So the for expression here, without you knowing it, is actually what's being called a monad. And the zip method here, which is provided out of the box in Scala, is called applicative functor. So by looking at example code like this, you can actually understand what's being done and not these weird names. But I really encourage you to dig deeper into functional programming. I hadn't done much before I entered the Scala world, and it has definitely turned me into a better programmer. I'm thinking in different ways now that I'm using functional programming. Okay, so finally, I'm going to give you some examples of the best books out there right now, that at least that I think are, or the ones that I have read about Scala and Akka. So first we have the sort of the Bible, which my colleague Martin Odarski has written together with 2 other people. So that sort of goes through the whole Scala language and touches upon everything. I'm not sure it's not up to date with 2.10, but I think it's on 2.9. Does anyone know Scala? No? Okay, I think it's 2.9 something, the latest version. But if you want to, I mean, it's definitely a good resource for 2.9, and then you can get into the 2.10 features yourself, I guess. Okay, so that's sort of the language specification going through that. The next book that I would like to recommend is Scala in Depth, which is something that Josh Suarath from Typesafe has written, and it's really great. I like it a lot. And then if you're into Akka and want to learn more about Akka, then the Akka concurrency is an amazing book. I like it a lot. I laugh a lot when I read it. It's written in a modern way, and it's absolutely great, by Derek White. So I really recommend you to look into that. And finally, a really great book by Runar and a couple other guys is Functional Programming in Scala, which really digs deep into functional programming. And I learned really much from this book. So those 4 books will turn you into a better Scala developer for sure. So finally, if you have any questions about Scala Akka and Play, Typesafe, we have a booth downstairs. We encourage you to swing by and talk about any of the topics that I just went through, or Akka, or Play, or programming in general. So that's it for me. Thanks.